So yeah, welcome back to another math video. And so today we're going to be talking about infinite series, right? And so infinite series, if it's not geometric and it's not arithmetic and it's not a p-series, well, arithmetic always diverge. So rather, if it's not geometric, it's not telescoping, and if it's not telescoping and it's not a geometric series with a ratio less than 1, we can't really just tell right off the bat, right? And so we have these tests that we've created to kind of tell us, does it diverge or does it converge, okay? And so the first test I like to implement is called the no-hope test. So I'll write it up here, really asking diverge or converge, okay? And once again, converge would mean that if you're thinking about it graphically, all these sums added together is going to add to some finite value eventually, or it's going to converge to some finite value, whereas divergence could be thought about like this, which is where it's kind of going to go on to infinity. It's going to grow forever. Sure. And I feel like that's pretty obvious through the geometric. And so we're going to start with our no-hope test, okay? And so the no-hope test pretty much says, if our sequence, so this is our sequence in here, if the limit as n approaches infinity, n is just our variable, of the sequence does not equal 0, then there is no possibility this sequence can converge. Whereas if it does equal 0, there is a chance it could converge. However, the NHT, no-hope test, does not prove convergence, okay? So NHT says, and we'll call the sequence in here a sub n, just for formatting's sake, I guess, says that limit as n approaches infinity of a sub n says that if n does not equal 0, then no chance of convergence. Okay? So, no chance of convergence. Cool. And so now, if we think about, let's take the limit of this. So we have 2n squared plus n over 4n to the 7th plus 3 all in a radical, okay? And so if we kind of just compare the growth of this, we know that this is going to be, we have a power of 7 down here, a power of 2 here, but this isn't a radical. And we can kind of ignore these side things because they're not really going to affect the end behavior, which is what we are looking at when we're doing limit as n approaches infinity, because if you think about, like, for example, y equals x squared, this is just going to go like this. So we're looking at the end behavior, which would be obviously diverge to infinity here. And so here we can see that, we pretty much have a 7/2 power on the bottom. This is not actually equal to, but we have a 7/2 power on the bottom, and we have like a 2n squared on top, and we know that this is 3.5, whereas this is 2, so this grows faster than this, thus this is equal to 0. Okay? So, now that we know it definitely doesn't, now that we know there's a chance of convergence, rather, we're going to continue on with the test, okay? So I'm going to erase this now. And so, looking at this now, we can see that, we could do an integral test. However, the improper integral of this from 1 to b of limit as b approaches infinity would be incredibly difficult. You'd probably have to split it, integrate one part by parts, integrate the other part by parts, and this is kind of a doozy to deal with even then. So, yeah, it's not a fun time. Maybe you'd even have to do a trig sub, or I don't even want to think about that, right? And so that's definitely not the way to go. Okay, now let's think about our next test. Is this a p-series? I don't think so. It doesn't have this form in any way of n to the p. Okay, now we can think about our alternating series test. Is there something in here that's going to oscillate between a negative and a positive? No, it's not obvious if there is, right? So ignore that, okay? So now we can think about our comparison test, right? And we can see with our comparison test, we know that a direct comparison test would say, if we find something that's either smaller or larger than this, for all n values, and that thing converges or diverges, then we can say this does as well. However, it'd be kind of difficult because this doesn't resemble anything directly. So instead, we're going to be using the limit comparison test. I'm going to call it the LCT. And the LCT tells us that the limit as n approaches if the limit as n approaches infinity, and we'll call this top one a sub n, and that's why I titled it here a sub n. And then we have a b sub n, which is what we're going to choose, right? I'm sorry, let me actually go back, that's my bad. We're actually going to start by trying to find something we could compare this to, right? And so as I keep prefacing, we're really looking at n behavior, right? And so when we're looking at n behavior, this 3 and this n, they don't really matter. They're not going to, this is just going to move it slightly, and this one's going to move it to the left 3 units. And so as we're going to infinity, that 3 units does not matter, okay? So to my point here, that means that we can kind of say this. It's a little bit of a stretch, but we can say that this is pretty much 2n squared over square root of 4n to the 7th. And what we're really looking for here is the growth order slash the end behavior, okay? And so the end behavior of this, we're going to have with some, let me pull you guys forward here a little bit. And so with some simplification to 2n squared over 4n to the 7th, we can say, okay, we have 2n squared on top. We can agree with that. And if we just distribute this radical in, we can say that this is 4n to the 7/2 power, but we know the square root of 4, right? So this is really just 2n to the 7/2 power. Oh, nice. We can cancel now. Beautiful. So now, we also have the same base, and that tells us when you have like, we'll call it a to some n, b to some n, you can do, a to some n, and let's call this just another, we'll call this e. This is the same thing as a to the n minus e, right? And so the same thing can be done here, where we can say this is similar to, or where this is exactly n to the 2 minus 7/2. We know this to be n to the 3/2 negative. Okay? So now we've kind of found our thing we're going to compare it to. We're going to compare this to 1 over n to the 3/2 power, where this is a series and n is equal to 1. There you go. Okay? And so now kind of what's important here is that, do we know the convergence or divergence of this easily? And the answer is yes. We know that a p series is when you have 1 over n to some p value, some integer value p, okay? And so we know just based on that, because p here is 3/2, p equals 3/2, and 3/2 is greater than 1, thus, we'll call this b of n, thus b of n converges, okay? So now that we've found our comparison, we're now going to use the limit comparison test. And as I was saying earlier, until I got distracted, the LCT is basically saying limit as n approaches infinity of a sub n over b sub n. And if this is equal to some finite number, it either converges or diverges, okay? Okay? And so we know that. So now, by using that, we can say that limit as n approaches infinity of 2n squared plus n over square root of 4n to the 7th, excuse my writing, all of this over 1 over n to the 3/2 must be, we're going to just solve this basically. So now we can reciprocate this up, and we can see that this is equal to the limit as n approaches infinity. I hope you guys can see that. This over just a little bit. Limit as n approaches infinity of, I'm recording a video. Get out. I'm sorry about that. N to the 3/2. Then we have 2n squared plus n. All of this is over. Radical 4n to the 7th plus 3. Okay. And now we can see here, if we just distribute this in, we're gonna get a 2n to the you're gonna add these, right? And so when you add these, you're gonna get 2n to the 7 halves. Oh, and now we know that when we're doing this, we can just compare the leading coefficients. So we know that this limit is just equal to 1, okay? And thus, this series converges. Thank you, guys.